Okay, so for the last week or so, we've been working on, like I stated before, we've been working on multiples. We've been working on factors and factor pairs. And now we're going to get into prime numbers and composite numbers. So where we left off yesterday, it should look familiar if you were with us, as we were looking at skip counting columns for counting by twos and counting by fives. And we found some common multiples was our key word at the end of the lesson. Some common multiples that were shared by both 2 and 5. Okay, and we found that every 10th number, so every 10s, 10, 20, 30, 40, 50, 60, all the way up, are common multiples for 2 and 5. So really what we finished on yesterday was like the entry task warm up for what we're going to do today. So we're going to jump right in to the activity. It's called card sort area. It's 3.1. If it's in your packet, it's page 9. So I think it's the very first page of what you would do in the packet. You had a front page on the packet where there are some rectangles that you could cut out if you wanted to. You don't have to. If you follow along in class today, we're not going to cut them out. We're just going to write on them and sort them from there. So it would look like this. I'll scroll down. So you should have had a first page on your packet that looks like this or something similar. Okay, so our first activity we're going to do is this card sort area. Now, I wish that you guys were in class because, we would get our scissors out and cut out all the shapes and sort them by area like we're going to do here, but we have to do it virtually, do it digitally. So if you're playing along at home, have that sheet in front of you. If not, just have a blank piece of paper in front of you. You don't need to draw the rectangles. We're just looking for the areas. Malia, do you have a question? You're on mute.
Where is it in the workbook?
In the workbook, you don't have this card sort like pieces here, but you should have this page, 3.1 card sort area. It would be page 11 would be my guess because they're 2 ahead of the packet pages. So page 11, and it would look like this. Do you see it? Give me a thumbs up. Yeah. Okay. So this is the activity we're going to do. We'll give you a set of cards to sort. Unfortunately, we can't, but we're going to view it on the screen. And then it says sort the cards by area. Record your sorting results. Be prepared to explain your choices. Okay, so what we're going to do, looking at this page here, in order to sort the cards by area, we need to know the areas, don't we? So what I would like you to do is on your own, using the skills that we have learned over the last week plus, find the areas of each of these rectangles. Okay, there's an A card here, a B card there, C, D, E, F, G, and H. So I want you to, you don't need to draw it if you're doing on a separate sheet of paper, but just say the area of A is, and you find that area. The area of B is, and you write the area, and so on. And if you get far enough, sort them in their groups on which ones are equal. Okay, does that make sense what you're doing? Finding the areas? Okay, awesome. Eileen, do you have a question? I see your hands up.
On what page is that?
What page?
Mm-hmm.
So the page in the workbook is page 11. It's the second page in your packet if you have the packet, but you don't have these cards here that I'm showing you because I would have given them to you if you were in class. Does that make sense?
Mm-hmm.
Okay. So again, if you have the packet, you have these. If you have the workbook, then you don't have these.
Okay.
Okay, so I'll give you, I don't know, 4-ish or so minutes to work through this. Then I want to call on you guys and have you give me your answers that you found for each of these areas. Okay, so about 4 or so minutes. If you have questions, raise your hand. If you finish, you can raise your hand. Tia, would you mind moving from in front of the TV? Because it's distracting me. There you go. That's better. Or if you need to go to a separate room too, so you're not watching it. Find a good quiet spot. Those who I can see their cameras on, you're doing a great job. If you're not showing your video, that's okay. But I trust that you're doing that work because I'm going to call on different people to give me answers for these areas here. And when you're finished, go ahead and put your hand up. You have probably 2 more minutes left. Thank you, Eileen. Eileen, do you have a question or are you finished?
So do we find the area?
Yep, find the area of each of those cards. So
Okay.
you should have 8 areas. And then when you find the areas, sort them together, group them together on the ones that are the same. Okay, or just note that somewhere. Adelina, do you have a question or are you finished?
Question.
What's that?
Okay. Yeah. Question. Do we separate them from the same area?
So you group them together. If there are 2 or more cards that have the same area, then write them down. Say cards A, C, and F are the same if those are what you found.
Cards. Okay.
So group them together if they have the same area. Camila, are you finished or do you have a question?
I'm finished and I also have a question.
Ooh, okay. Go for it.
So when you were like telling Adelina, like explaining it, and when you said grouping, do we like add up like the same numbers?
So once you found the areas, what I want you to do is if you see that 2 or 3 are the same areas, then just make a note of that and say A, C, and F, if that's what it is, all have the same area.
Okay.
Does that make sense?
Yeah.
Okay, awesome. Okay, about 30 more seconds. Whether you're done or not, we're gonna keep on moving. All right, let's go ahead and get this up on the board. So looking at the first card, can someone share with me the area and how they solved it? Malia.
For A, I 8 times 3
Okay, 8 times 3
equals
I'm gonna change
24.
it. So 8 times 3 equals 24. All right, very good. Malia, do you want to give me maybe B and C as well?
Yeah, for B, I did 13 times 3.
Okay, it's close. It's actually 12 rows. I know it's small, kind of hard to see. But can you tell me what 12 times 3 is?
26.
So what did you get for 13 times 3?
39.
All right, so if we're moving back, skip counting backwards 3 from 39, what do we land on?
36.
Yeah, 36. Nice job. I should have noted that there are 12 there. It's kind of hard to see.
And
All
for
right,
C,
and then for C, Malia.
1 times 18. Well, 8. 18. I did, and it's just 18.
Yep, it's just 18. So an area of 18. So we have 24, 36, and 18 for our areas. All right. Let's see. Adelina, do you want to give me D, E, and F? Adelina, are you there? I might need to pass it off to someone else. Camila, do you want to try those ones? D, E, and F? Give me the areas and how you solved it.
For D, I did 6 times 3
Okay.
equals 18.
Very good.
And for E, I did 4 times 6 equals 24.
Very good. And then what about F?
And for F, I did 6 times 6 equals 36.
Very nice. Good job, Camila. Good job, Malia. Can someone give me the last two? Eileen?
1 times 7 equals 7.
Yep.
And then 4 times 9 equals 36.
I heard you whisper it.
I can't tell you the answer.
36.
Yeah, 36. 4 times 9 equals 36. Okay, now the second part of this activity was to group them together. So who can tell me the groups based on the area? Which ones go together? Camila?
Like, which one are the same?
Yep, which ones are matches?
Oh, 36, 24.
Okay, so 36, 24 has a match.
18.
18, and then 7's all alone. Camila, which ones have 36 for an area? Which letters?
A. I mean, no, not A. B. F. And H.
D, F, and H. Okay. What about 24?
A and E.
A and E. What about 18?
C and D.
C and D. And then G is the only one for 7, isn't it?
Yeah.
Okay, very good. Thank you, Camila. All right, here's the next thing I want to test you on, okay? So for 36, we have a colon there. I'm going to zoom out a little bit, scroll over. So for 36, we have a few different rectangles that we made. We have 12 times 3 equals 36. We have 6 times 6 equals 36. And we have 4 times 9 equals 36. Okay, so we have 3 different rectangles that we can make here as of right now that we show. Let me put this in my little rainbow that we make. Factor pair rainbow. Zoom out again. There we go. Okay, here's a question for you. Are there any other rectangles we can make that have an area of 36? Okay, maybe another way of thinking is there another factor pair that makes 36, or maybe even a couple? And if so, what could it be? Daniela, I see your hands up. Do you want to try answering that? Is there another multiplication factor pair that gives us 36?
Forgot to put it down.
Okay, that's all right. I see a few hands up right now. Malia, go for it.
That could make 36.
Yep.
So the ones that could make 36 is 9 and 6.
Well, we have 9 and 4 already. What did our factor rainbows always start with? What did we talk about yesterday?
1 and 36.
Yeah, there's an option for us. 1 and 36. That equals 36. Very good. So there's another one that we can make.
And it's 2.
Are you trying to come up with one for 2?
Yeah, but I don't know what.
What happens if you cut 36 in half? You divide 36 by 2. It's a tough one.
2 times.
Let's think about what's close. Okay, 36 is close to 40, right? Okay. Well, what's half of 40? What do you need to add twice to get 40?
2 4.
Well, to get to 40, if we use a number twice, add it together, we would add 20 twice, wouldn't we? 20 plus 20. Okay, so we know that 20 is half of 40. So now if we're looking at 36, it's a little less than 40. So what's half of 40, or 36 is going to be a little bit less than half of 40. So it's going to be a little less than 20. Does that make sense? Okay, so for the sake of time, I'm going to give it to you this time because we have a lot of other things to do. And the question was just to get us one more factor pair. And so 2 is going a little over. 2 and 18 is another option too. All right, if we skip count 2 or by 2, 18 times, we'll get 36. Or if we skip count by 18 twice, we'll get 36. So there's a couple options. Okay, what about 24? 24, I see an 8 by 3. I see a 4 by 6. So if we were to make our factor rainbow, we'd have 3 and 8, 4 and 6. What's another factor pair that we can find? I see Malia's all over it, but I want to hear from someone different this time. Good job, Malia. Malia's already proven that she knows what she's doing here, so I want to make sure that other people show it too. What's another factor pair for 24? We have 3 times 8, 4 times 6. Tania.
Yeah.
2 o'clock open.
Tania, do you have an answer? Or another factor pair for 24? I think we lost Tania. Jocelyn, I see your hands up. Do you have another factor pair?
24 times 1.
Yeah, that's a good one. 24 times 1. All right, so there's another one that we can do for 24. Coming up with all sorts of ones. And then we had 18 as well. Okay, so 18, let's see, we had 1 times 18 equals 18. We had 3 times 6 equals 18. And that's all I see. So we have those two there. So let me make my factor rainbow. 1 times 18. We have 3 times 6. Okay, what's another one that we can have for 18? Katie, do you have one?
No, I have one for 24.
Okay, can you hold tight to it? Because we need to keep moving.
I know.
Okay, Camila, do you have one for 18? But thank you, Katie.
9 times 2.
9 times 2 or 2 times 9? Yep, that's a very good one. 2 times 9 gives us 18. Very good. So let me circle that one. Oops, get out of this. Okay, and now let's go to 7. 7, we had 1 times 7 equals 7. There's our factor rainbow so far. Is there another factor pair for 7? Can we skip count by a number that's not 1 and land on 7? Leah, what do you think?
You could skip count by. Oh, I really thought it was 6. 3.
Yeah, if it was 6, then yeah, 3 would work and 2 would work too. But let's try some numbers. Okay, if we want to skip count by 2, we have 2. Oop, I want a little bigger marker. Oops. All right, 2, 4, 6, 8. Oh, 7 would have been right in the middle there. We didn't land on it. 3, 6, 9. Oh, 7 would have been right there, but it's not there. Doesn't land on it. 4, 8. Oh. 5, 10. Nope. 6, 12. Nope. So it looks like 7 is the only one that we have. It's the only rectangle. 1 by 7 is the only rectangle that would give you an area of 7. All right, so what does that mean? Well, it means
It's a prime.
that it's a what?
I forgot the word, but prime.
Prime number.
Yeah.
Yeah. Yeah, I'll scroll over here and give me some room to write. Let me get my notepad open. Yeah, since there's only one factor pair for 7, 7 is a prime number. There's only 2 numbers that can be multiplied together to give us 7. It's the only factor pair. It's 1 and itself. Okay, you see on this factor rainbow, there's only one band connecting the 2 numbers, whereas the other numbers, there's multiple bands that are connecting the numbers. Okay. Let me use a different color here. Let's use blue. Okay, so we have prime number for 7. The other numbers have another word for them. Composite number. Let me grab this. Oops. Grab all of it. There we go. Let me copy, paste, paste. There we go. Save me from writing it 2 more times. So there are only 2 classifications of numbers when it comes to prime or composite. It's either prime number, meaning there's only one factor pair, 1 and itself, or it's composite. So there's 2 or more. So it can be just 2 factor pairs and it's composite. It could be 3 factor pairs like these. It could be, 5 factor pairs. It could be 100 factor pairs. It's still just a composite number. Okay, there's only 2 names: prime number, composite number. Okay, does that make sense? Give me thumbs up, sideways, down. Okay, very good. So when you make your factor pair rainbow, if you only see one band, it's a prime number. If you try to make a list of all the factor pairs in a multiplication expression, like 1 times 7, and you only get the 1, it's a prime number. If you try to make a rectangle with an area of 7 or whatever it may be, and you only can find one rectangle for it, it's a prime number. If you're able to find multiple rectangles, multiple multiplication expressions, or multiple bands on the rainbow, it is a composite number, no matter how many there are. If there's 2, if there's 100, if there's 3, whatever it may be, it's composite number. Okay. I saw some thumbs up there when I checked in, so we're going to move on and get some practice working on this, okay? Let me scroll back over and scroll on up. Okay, this was posted to your team's assignment. Let's see, we're 10:50, so we're already a little past time. I want to introduce this first, and then I'll let you go, okay? 3.2 primer composite. This was posted on Teams. It's in your packet if you have it. It's in the workbook too. Okay, so it should just be the next page from this card sort area that you had. Whether it's the workbook or the packet, it's the next page. Primer composite, that's the name of it. The instructions say, complete the table, explain or show your reasoning. Use each pair of side links only once to determine the possible number of rectangles. So for example, as it says, if you make a rectangle with 4 units across and 6 down, you don't also need to do 6 units across and 4 down, because it's the same rectangle, it's just turned 90 degrees, right? If you have the packet or you're looking at it on Teams online, I completed the first 2 for you already as an example. But let's work through those together as a class so that those with a workbook can get caught up on it too. So let me draw my, I drew a line for you guys, not super straight, kind of squiggly at the end, sorry. What I want over here in this column are the numbers of possible rectangles, whether it's 1 rectangle, whether it's 4 rectangles, whatever it is, that's where the number will go. That's the number sign. Okay, let me undo those. In this column, you may not be able to fit all of the multiplication equations that are expressions that give you 2 or 10 or 48, whatever it may be, but I want to see maybe 2 examples of it. Okay, and then over here, I want you to list, all right, now that I know how many possible rectangles there are. Is it prime or composite? So let's look at 2. What are the possible rectangles or rectangle that has an area of 2 square units? What is an example of a rectangle with 2 square units? Looking at this first row here, 2 square units. Jocelyn, is your hand still up from earlier, or do you know the answer to this question?
It's from earlier.
It's from earlier? Okay. So let me ask it a different way. What numbers can we multiply together to give us 2 as the product? What numbers can we multiply together to give us 2 as the product? If you wanted to make our factor tree, remember our factor rainbow, Our factor rainbows always started with a certain number. Camila, do you want to answer?
1 times 2.
Yeah, 1 times 2. Actually, I write it right over here. 1 times 2 gives us 2. And if I want to do the factor rainbow over here, we have 1, we have 2. And there's our option. Okay, let me let Jocelyn back in real fast. There we go. All right, so we have 1 and 2. Are there any other options for us to multiply 2 numbers together to get 2? Well, if we start at 1 in our factor pair rainbow, the next thing we would try is 2, but we already have 2. So the only factor pair for 2 is just 1 times 2. So the possible number of rectangles is just 1. Okay. Camila, do you want to answer if this is prime or composite?
There's also another one. 2 times.
What is it?
2 times.
Yeah, but that's what it says up here. Use each pair of side lengths only once to determine. For example, if you have 4 by 6, you don't need to do 6 by 4. So we actually found all of the rectangles for it. We could do 2 times 1 and flip-flop the columns and the rows, but it's still the same rectangle, isn't it? It's still the same pair of side lengths. So yes, you could flip it, but there's only one unique rectangle. So is this prime or composite, Camila?
Prime.
It is a prime number because there's only one factor pair that works for 2 square units or gets you an answer of 2. All right, last one we're going to do. I know we're running long. I'm sorry, but I want to make sure that you guys have a good start on this. What are the factors of 10? What are the factor pairs if you want to make our factor rainbow? We always start at 1. So if we wanted to put the 1 down and connect it to something, what would we end up with on the other side? I'm going to stick with Camila. She's really active today. I love it. And we're running out of time, so I want her to help me.
You could do 5 times 2.
Okay, so we have 2 and we have 5. Connect those together. Okay, and now what about 1 times something to give us 10?
1 times 10.
Yeah, 1 times 10 is another one. Are there any other ones?
No.
No, there are no other options. We could try to skip count by 3, but we wouldn't land on 10. We could skip count by 4, but we wouldn't land on 10. And then we already have 5, so we know we've tried everything. So there are 2 possible rectangles. And Camila, is that prime or composite?
Composite.
It is composite. All right, those are the only 2 options for us to use. Either there's 1 possible rectangle and it's prime, or there's 2 or more and it's composite. Okay, So I only see a few cameras up there. Let me stop sharing my screen. So you should be able to see me. I'm going to come over here. I'm going to end the recording.